3, lesson 15 is all about powers and roots. So the goal is to be able to take an expression and use exponents to simplify it, and even take a number and write its prime factorization using exponents. So if we look at a number, okay, 5 to the third, we would say the base is the number used as a factor. Well, if we're thinking about that, the number that is being used as a factor, we're saying, what number am I wanting to multiply together multiple times? So in this case, we would say the base is 5. An exponent, well, that is, we define that as showing how many times the base is being multiplied. In this case, it's 3. That base of 5 is being multiplied by itself 3 times. And lastly, the power. The power tells us that this is the entire problem, including base and exponent. So a lot of times we hear this word used by saying, well, 5 to the power of 3, or 2 to the power of 8, or 3 to the power of 3. It's the entire problem. So if we look at something like this, 3 to the 4th power, well, 3 is the base because I'm taking 3 and multiplying it by itself 4 times, because 4 is our exponent. What does it really mean? Well, it means that we have 3 times 3 times 3 times 3, which when we simplify or evaluate, we get 81. Okay, so 3 to the 4th really just means I'm going to take 3 and multiply by itself 4 times. And whenever it asks you to simplify or evaluate, that means that we want to get a final answer and multiply it out. So the base of 4 to the 6th is 4. And the exponent is 6, okay? So we'd say the base is 4, exponent is 6. The base is 2, the exponent is 4. So when I go to simplify this out, I would do 4 times 4 times 4 times 4. Oh, 2 more. Times 4 times 4. And I could start multiplying this out. Well, 4 times 4, that's 16. Times 16 times 16. Well, 16 times 16 is 256, and I'll multiply that by 16 and get, let's see, 36, 30, 33, 12, 15, 6, 5, and 1. So we get a final answer of 3,096. Okay, if we want 2 to the 4th power, we would be doing 2 times 2 times 2 times 2, which is just 16. So we can simplify, evaluate. Other terminology that we often use is if it's to the 2nd power or an exponent of 2, it is said to be squared, just like if you're thinking of area. Or 3rd power, exponent of 3, is cubed, or like volume. But all of the other ones, 4th, 5th, 6th, 7th, 8th, 9th, 10th, we don't really have a special name for them. They're just to the 4th power, 5th power, 6th power, 7th power, 8th power, and so on. Write the product as a power. Well, if I have 8 times 8 times 8, that's telling me that the base is 8, and I'm multiplying it together 3 times. Second one, base is 5, multiplied together 6 times. Base is 6, multiplied by itself 5 times. All right. Evaluate x squared when x is 9. Well, what we're saying here is that if I start with x squared, I'm going to replace x with 9, so that I get 9 squared. Well, that's just the same as 9 times 9, which is 81. So we can replace our variable with an actual number and then do the operations. So like b to the 3rd. That's like saying that we have 7 to the 3rd because b is 7. So we really have 7 times 7 times 7, which when we multiply together is 343. Okay, you can multiply it out and check that. All right. Write the prime factorization of 72 using exponents. Well, this is when we take 72 and use our tree and to say, all right, well, some factors are 8 and 9, but those aren't prime, so that's 3 and 3. 8 can be factored into 2 and 4, which can go smaller into 2 and 2. So we actually have 2 times 2 times 2 times 3 times 3, which we can use exponents to write as 2 cubed times 3 squared. A square tile is 1 foot on each side. The area in square inches, though, if we think about this tile, well, if I have 1 foot on each side, that's the same as 12 inches. Okay, 1 foot on this side is the same as 12 inches. So to get the area, I would do 12 times 12, or 12 squared, which is 144. So we get 144 square inches. All right. 144 is a really nice number because it is a perfect square, which we'll talk about in a minute. Express these expressions with exponents. Well, we can see that the first one is grouped very nicely. And those right there, those 3 x's multiplied together, that's just the same as x to the third. Those 6 y's can be shown as y to the 6th, and those 2 z's are z squared. Everything in here is being multiplied, so in our end result, x to the third, y to the 6th, and z squared is multiplied as well. Now the next one isn't organized quite as nicely, so because multiplication is between all of these, I can move some things around to help me out. I can say, I'm going to move all of my 2's in the same place, because guess what? Those are all disconnected. Because of multiplication, we can move them around. And I'm going to move all the 3's in the same place, all of the x's in the same place, and all of the y's in the same place. Even though it says something like 3y, those are disconnected. We have a 3 and we are multiplying by a y, which means I can separate them to go as a 3 and as a y. And we can use our exponents. So 2 cubed times 3 squared times x to the third times y to the third. Or if you want to multiply it out, that's 72 x cubed y to the third. X cubed, y cubed. Okay? To show another example, what if we had something like 3x times x times y times z times y times 4? Well, I could say I'm going to put my numbers together, 3 times 4 times x times y times z. I just rearrange them. And then I can say, well, that's 12 x squared y squared z. Okay? Move them around and then show them with exponents. We have some more vocab words because as we're talking about exponents, it's natural to also talk about perfect squares and roots. So perfect squares is a number that is the square of an integer. Radicand, that's the number that's under a radical symbol. And square root is a number whose square is the number times itself. What we're really saying here is if I want the square root of 81, I'm looking for a number that times itself gives me 81, which is 9. So, first 15 perfect squares, you can think of things like 1, 4, 9, 16, 25, 36, 49. Okay, it goes on and on and on. It's good to know those perfect squares so that as we're simplifying things, you can realize when we have perfect squared multiplied by a number. So we have our square root symbol, okay, a radical symbol, and the number underneath, like the square root of 50, 50 is the radicand. Or 2 root 18, 18 is the radicand. Just some terms that we'll be using. If we look at our numbers 1 through 100, all on that diagonal, those are our perfect squares. Okay, and there's a little mistake here. I'll fix it. It should be 64 there. Okay, well, and if we're looking at all of these, then we realize that if I have, this is just a normal multiplication chart, if I have 9, well, that makes a perfect square with its factors 3 times 3, or 36, perfect square with 6 times 6. There's a reason these are called perfect squares, and it's because they create a perfect square with their factors, with their square root. Okay? So if we start looking at some of these square roots, I am looking for a number times itself that gets me 81. Well, 9 times 9 gives me 81, so my answer is 9. Or the square root of 121, that's 11, because 11 times 11 is 121. Or if I want this negative square root of 2.25, well, I know that 15 times 15 is 225, so it would make sense that 1.5 times 1.5 is 2.25, and then just like with absolute value, we do the square root first and then add the negative. Negative square root of 144, that's negative 12 for the same reason as before. And this one right here, well, that's 5 over 8. Because the square root of 25 is 5, and the square root of 64 is 8, but we keep it as a fraction. Because 5/8 times 5/8 is 25/64. Okay? So here are some other practice problems. Think about if you have something like this. This is a cube root where we're saying I am actually looking for a number times itself 3 times that gives me 8. Okay? And if you're thinking about it, that number is 2 because 2 times 2 times 2 gives me 8. Okay? So that little number itself tells me that I have something a little different. I'm looking for a number times itself 3 times that gives me 8. Well, I hope this was helpful for homework and for studying.